Hi, I'm Tilman, and I'm thrilled to present the following work on collecting cognitive performance metrics through games. The work originated from a collaboration between my co-authors Machulla, Niels, Henze, and Henze. Cognitive performance, such as alertness, fatigue, and decision-making abilities, they all fluctuate throughout the day, partly due to our inner clock. And in this research, I will show you how we use performance measures obtained from mobile game data to model players' varying alertness levels. So according to the established theories on sleep-wake regulation, there are really two processes that underlie our cognitive performance fluctuations. One, the homeostatic process, which basically manifests itself as a gradual decrease in alertness during wake periods. And then there's the circadian rhythm, which is determined by our biological clock and determines hours of the day characterized by a particularly low or a strong sleep drive. Now, there are validated tests to determine people's alertness. Rectal temperature is an accurate measure, but also reaction times and tests of higher cognitive functions are a good measure. But consumers may not want to perform these tasks for an extended amount of time before their devices really figure out their alertness fluctuations, so this should really be done unobtrusively instead, by tying alertness measures to, for example, interaction data, such as text typing or gameplay. And so we designed a game for Android called Circadian Racer, based on an alertness toolkit which we released a few years ago. And the game basically models three validated alertness tasks. One, it comprises a gear changing task, which is basically a reaction time task, also called a psychomotor vigilance task, or PVT. So the player changes gears as quickly as possible once the message speed up appears on the screen. And then there's a second game mode, which is an obstacle avoidance task, which resembles also a go-no-go task, or GNG. So two types of items basically appear in the driver's lane, obstacles in the form of cars that need to be overtaken, and rewards in the form of oil barrels which need to be collected. And then third, if the player does not swerve to the other lane in time, the car basically crashes into the obstacle, effectively launching the third game mode, where each car explodes into 4 parts, and the player is required to relocate the positions of their own car's debris after the rubble starts flying across the screen. This is effectively a multiple object tracking task, also called MOT. We also collected subjective assessment on sleepiness as a ground truth measure using the Karolinska sleepiness scale in the game. And so we pushed this game out to 30 study participants who were reminded to play the game multiple times throughout the day during a 2-week period. So here are the results. Reaction time increases by 3.5 milliseconds per level of self-rated alertness. So we found indications of homeostatic influence in all of these 3 subtasks. And the orange line here denotes the homeostatic process, causing a steady increase in reaction times or committed errors in the case of the multiple object tracking across the day. Our omnibus test also detected significant circadian variations, but pairwise comparison between hours did not yield any significant differences. So we were able basically to confirm our hypothesis that time of day dependent patterns of alertness and cognitive performance can be extracted from game data collected in the wild, as we found indications of homeostatic process in all of these 3 top tasks. So systematic persistent changes could be detected by our statistical model. And so the game we presented is tightly coupled with the intended measures, which is a step towards less controlled conditions compared to previous work. It does not necessarily imply, however, that any game metrics may be equally effective in measuring alertness changes. Game designers who would like to incorporate alertness-related features into their gameplay will need to look out for metrics that generally represent reaction times, quick decision-making, and visual multitasking. And that's it from our side. You can find the paper with all details in the proceedings of MobileHCI 2020. Thanks for watching.